13.5 billion years ago, the universe was mostly hydrogen gas, with gravity doing what gravity does, which is to slowly pull it into vast clouds. Hydrogen is the simplest of gases, but it has a very special property. It's a tremendous source of power. Heat hydrogen to around 10 million degrees and it begins to produce the energy that makes the stars shine and supplies the universe with warmth and light. To see how this works, let's imagine we could make a small star here on Earth. First, we need plenty of hydrogen gas. About a sports stadium full would be perfect. Next, we need to imagine squishing this hydrogen together, just as gravity does in space. As the hydrogen compacts, the atoms of gas start bouncing off each other, and the temperature begins to rise. By the time it's compressed down to the size of a soccer ball, the hydrogen reaches the critical 10 million degrees, and a process called nuclear fusion begins. The hydrogen starts to fuse together, making a new, heavier material, helium. With every step of this tiny bump and grind, some matter gets converted into pure energy. We have created a miniature star. Of course, if this was a real experiment, you wouldn't want to go anywhere near it. The energy given off, even from a star this small, would be devastating. Back in the early universe, the same process happened for the first time on a much, much bigger scale. Gravity compressed the hydrogen gas clouds over millions of years until deep in the center, the hydrogen became hot enough for fusion to occur. The first star burst into life, pouring its energy into the vast universe, a product of the laws of nature and the raw materials left over from the Big Bang. It was almost 1,000 times bigger than our own sun and burnt a deep blue. What's more, this star soon had company. The stars were turning on. This same process still happens in our sun, which is where we get the energy we need to live. But there was still a long way to go to get from this to where we are today.